let's decode the value of x which will satisfy this equation here involving logarithms. We have the logarithm of the quantity 2x minus 3 to the base 3 plus another logarithm of the quantity x plus 3 to the base 3 is equal to 4. To do this, we need to understand, apply, and be reminded of the important properties, processes, and operations involving logarithms. We're talking about here addition of two logarithms, and we have this important theorem or property in logarithms. If we have the logarithm, let's say a to the base b plus another logarithm of, let's say, let's not use b, c to the base b, we can just combine them into one logarithm. And this only works if we have the same base, because if the two logarithms doesn't have the same base, we cannot do this. Okay, in our given, the bases are 3, so we can do this. We can just combine them into one logarithm of the same base, but what will happen here is we're going to multiply the two coefficients. Multiply. The common mistake here is they will add because the original form is addition. No, we will just simply multiply them. Okay, so if we have the original given, the logarithm of the quantity 2x minus 3 to the base 3 plus we have the logarithm of x plus 3 to the same base 3, which is equal to 4. The entire expression for your left hand side can be rewritten into one logarithm, and you'll be multiplying the coefficients or the binomial expressions in this case, 2x minus 3, and you will have your x plus 3. And this would be on the same base 3, which is still equal to 4. Okay, now that is what will happen first, since we have the addition of two logarithms of the same basis. Next thing here is, before multiplying this entire two binomials, which will result probably to a quadratic trinomial, let's try to review this transformation. The logarithm of a to the base b when equal to, let's say, y, because x has already been used. If you have this logarithm of a to the base b, which is equal to a certain y, we can transform this, and vice versa actually, to an expression which is, you use the same base, the y or the equivalent will become your exponent, and this is equal to your a, which is the coefficient here. So from logarithmic equation, you will have exponential equation, especially if your y here is a variable. So applying that here, you will have your base 3. So you have 3, and 4 here will be the exponent of 3. Equal now to this two binomial under multiplication, 2x minus 3 and x plus 3. Or you could rewrite this in this manner. Let me move it here. You have 2x minus 3 and you have x plus 3 is equal to 3 to the power of 4. That's actually 81. Next here is from logarithmic equation, you will simply have equation here probably involving quadratic expression, as we are going to multiply this using the FOIL method. So 2x times x, you have 2x squared. The inner, negative 3 times x is negative 3x. Outer 2x times 3 is 6x. So negative 3x, 6x, you will have plus 3x. Then you have negative 3 and then times positive 3, so you have minus 9. Negative 3 times positive 3 minus 9 is equal to 81. Or you will have a form here which is 2x squared plus 3x. When you subtract 81 both sides so that this will be equal to 0, you will have minus 90. We'll have negative 9 minus 81. You have negative 90 equal to 0. Our goal earlier is to decode the value of x. So from here, we have a quadratic expression or a quadratic equation specifically. So we are going to factor this. We can factor this using AC way. You have AC method here, or AC way. Multiply your A and C coefficients. 2 times negative 90. So you also need to review your factoring of quadratic expressions. This is negative 100 80. Next thing here is we look for factors of negative 180, which when added will result to positive 3. Now, there are plenty of pairs of factors here, but since this is just the point here, the mission is only for logarithm, so that we will not waste time. I could let you review that on your own and simply give you the result here. The factors here would be, since it's positive 3, so you have positive 15 and negative 12. Okay, you may want to check that. 15 times negative 12 is negative 180, and 15 plus 12, you will get here positive 3. So that would mean your factor here, I'm going to use here 2x. Again, you may want to review the factoring here, and also 2x here. Don't worry if this will result to 4x squared, it will not return to 2x squared because something will be done later to the coefficients. Again, simply use 2x and 2x even if it will not become 2x squared, but you will see what will happen later. You will have it here plus 15 as given and minus 12 equal to 0. Of course, these two binomial expressions will not return to this quadratic equation, but when you divide this by its greatest common factor of 2, this would be your factors. 2x plus 15 times, divide by 2, you have x, divide by 2, you will have minus 6 equal to 0. These are now the more complete and more appropriate factors for the quadratic trinomial. You may want also to check this. 2x times x, 2x squared. You have 15x here. 2 times negative 6 is negative 12x, so 15x, negative 12x, that's positive 3. And of course, 15 times negative 6 is negative 90. Since we're solving for x, we can use here the zero factor property or the zero product property, which tells us that this is just equal to 0 when one or both of them is equal to 0. So your first here is this, 2x plus 15 equal to 0, and x minus 6 is equal to 0. So the first value of your x is negative 15 over 2. When you subtract both sides of 15 and divide both sides by 2. Here, you will have x, which is equal to 6. Now, we have two possible values of x, but let's examine whether both of them or only one of them or maybe none of them could satisfy the equation. When you look at the value of x, which is negative, when you substitute it to the first expression of 2x minus 3, you will have negative 30, divide by 2, right? You will have negative 15 because 2 times negative 15 over 2 is negative 30 over 2, or you will have negative 15 minus 3. This would mean for the first logarithmic expression, you will have the logarithm of negative 18 to the base 3. And it's not possible because you will get undefined if your coefficient to your logarithmic expression is a negative value. This is also true when you are going to substitute negative 15 halves to the second, because you will have a negative value as well. But when we examine 6, you have 2 times 6 is 12, minus 3 is positive 15, and the other side is positive 9. This is possible now, and this would mean the exact value for x that will satisfy the given equation is only 6. Going back to the process, we're able to start earlier by combining the sum of two logarithms of the same base by this property. And then we have applied this transformation, which lead us to this given quadratic expression. And since it's quadratic, we use the AC way. We factor it using this method, or you have your own method that you could use. And after here, the zero factor property, which tells us that this is only true if both of them equal to 0. We have two possible results, but only one of them could satisfy the equation. And here, that's mission accomplished.